Hello and welcome to the Q3 test review. So let's jump right in it. We have number one is an absolute value problem. And remember that absolute values, unless it equals 0 when the absolute value is isolated, there's always two solutions. So first thing you're supposed to do, get the absolute value isolated. So we have a subtract 1 and we have a times 5. So the reverse order of operations, to get it isolated, add 1. Then you have 5 times in absolute values x minus 7 over 3, and that equals 10. And now we have to divide by 5. Divide by 5. Now I'll work this out over here. Up here. X minus 7 over 3. We're taking the absolute value of that, and it equals 2. So it equals a positive number. So that means that we can keep going. If it equals a negative number, there's no way an absolute value, taking the absolute value of something, will equal a negative. That would be a no solution. But in this case, since it equals a positive solution, we'll break it down. So once you get to this step, there are always two solutions. One is the positive, and one solution incorporates the negative. So you multiply the right side by -2, right side always. So now you solve each one separately. So the first one here, multiply by 3, multiply over here on the right side by 3. You get x minus 7 equals 6, add 7 equals 13. So that's one of your solutions. And then over here on the right, multiply by 3. So you solve each equation separately. You get x minus 7 equals -6, add 7, and you get 1. So you have two solutions here, x equals 13 and x equals 1. Moving on to number 2. Identify all expressions that are equivalent to the problem shown below. So we have a radical, and when you have a radical, you have to rationalize the denominator. Right now it's square root of 5 is an irrational number. So we got to make it rational in the denominator. And how you do that is the square root, you multiply by another of the denominator. So it's multiply by one more square root of 5x. What that does is when you multiply straight across the fractions, you have the numerator becomes the square root, you multiply underneath. 5 times 5 is 25. X to the third times x is x to the fourth. Over 5 times 5 is 25 in the denominator. X times x is x squared, and then the next step is to simplify. Square root of 25 is 5. Square root of x to the fourth, so you can take out two pairs of x's, so it's x squared, over, and there's nothing left of the square root, so no more square root. The denominator, square root of 25 is 5. Square root of x squared is x. And now we can even simplify further. So we look at our coefficients on our monomials in the numerator and denominator. 5 divided by 5, 1, and x squared over x over 1. And so now we just multiply what's left. 1 times x is x over 1. We don't write divide by 1, so it's just x. So b. 3, sum up the infinite series. So anytime you see infinite series, infinite, we're talking geometric infinite series. And so you look on your formula sheet, and there's a formula, and you'll see this infinity here. So that's how you see infinity. You go into that formula. So it's first term divided by 1 minus the common ratio. So to find the common ratio, you take the second term and divide by the first term. 25 over 50, which reduces down to 1/2 or 0.5. So let's substitute 1/2 in for r. A sub 1, the little subscript, that just means first term. If there was a 2 there for some reason, then it would be the second term value. So we have the left side is just notation, math notation. You don't have to write it, but it's there for mathematicians to know what we're doing. We're summing up an infinite series. So 1 over 1/2. So you have 50 divided by 1 minus 1/2 is 1/2 or 0.5. Put that in your calculator, and you should get 100. So summing up this infinite amount of numbers in this series, it'll add up to 100. Number 4, describe the amount and type of solutions for the expression below. So I see a quadratic, so move every term to one side, and let's start the quadratic formula. So to do this, start the quadratic formula, you need to have your equation equal 0. And actually, since we're doing the amount and type of solutions, you don't need the whole quadratic. You just need the b squared minus 4ac. And this, by doing this, it'll tell you what type of solutions they are. So we have b is 1, a is 5, and c is -4. So let's substitute those in. So we have 1 squared minus 4 times a times c. So we have 1 squared is 1 minus 4 times 5 is 20 times -4 is 80. So it becomes a positive 80. So that's 81. So b squared minus 4ac, that's called the discriminant. And that's a positive number. That means that if you were to work out the whole quadratic formula, you will get 2 real solutions. If this is a negative number, that means you're going to get 2 imaginary solutions. And if this is 0, becomes 0, then you'll get 1 real solution. So in this case, we get 2 real solutions. So C. 5. Identify the x-coordinate of each point that is in the solution set. So here, first thing you're going to do, when you have equations, let's put them into the calculator. So the first thing you're going to have to do, though, is get both the equations equal to y equals. So the second one's already there, first one's not. So we need to move everything to the other side. So subtract 5x and add 11 to the other side. So you have minus 5x plus 11, and then we're divided by -4. So divide all the terms by -4. So you have y equals negative divided by negative is positive, so 5/4 x plus a negative. It's the same thing as subtraction. 11/4. So now let's put this into, it doesn't matter, but I'm just going to say we'll put it into y1, and then we'll put the second equation into y2. So I put them in the equation, or in the y1, y2, go to graph it. And our goal here is to look for x coordinate of the solutions. So solutions, when you have more than one equation, are where they intersect each other. So we have a second trace, so we go to intersect. And first curve, just always hit enter. Second curve, just hit enter again. Guess this is where you're going to move the tracer closer to whichever intersection you want to find. So the x-intercept, or the x-coordinate of the solution is -1. So that's one of our solutions. And I saw that it intersected again, so first curve, second curve, hit enter. And I guess move closer to the other intersection. You don't have to be on top of it, just close to it. And the other x-coordinate is 3.25. So we have x equals -1. Don't be fooled. That's a 1, not a -1. And x equals 3.25. And here we go. 3.25. Alright, so number 6, what are the vertical and horizontal asymptotes of the function? So first start out with horizontal asymptotes, and we have bigger exponent in the numerator than the denominator, so there is no horizontal asymptote. If the numerator's exponent is smaller than the denominator, then it would be y equals 0. And if the numerator's exponent was the same as the denominators, then you take the coefficients in front. So in this case down here in number 7, it'd be y equals 3/1, which is 3. It would be the horizontal asymptote. Looking for vertical asymptotes, let's factor. So we have x squared minus x minus 12. Well, a term is 1, so we do what 2 numbers multiply to -12 that add up to -1. That's -4, and x plus 3. And in the denominator we have x plus 4. So nothing cancels out, so there's no, that would be a hole. So then the next thing we look for is what will make the denominator 0, which in the factors. We only have one factor in the denominator, x plus 4. What value of x would make that 0? So you just set it equal to 0, and that'll get you what makes it equal 0. So x equals -4 is vertical asymptote, and then there's no horizontal. Alright, when you get an opportunity to do a graph for number 7, let's just put it in the calculator, put this in the calculator. You can do exactly what we did for number 6, but the calculator method's a little easier. So we have it graphed, and we'll go to graph here, and what we're going to do is we're going to compare. So I see the graph is above the x-axis, and I see D here is not above the x-axis, and C is not above the x-axis. Like both graphs are right at the x-axis, so that can't be right, and D can't be right. And let's look at comparing again. Alright, so it looks like I can't really tell, looking at the graph, which one it is. I guess this here, the left part of the graph, doesn't really, it gets really close to the y-axis. This one over here crosses the y-axis at 3. 3 here doesn't cross. So comparing these, B can't be the answer, so it has to be A. Alright, moving on. Which expression can be simplified to x plus 2 over x minus 4. So we're going to look to factor each. And so the factors of A, B, and C, those are all A is equal to 1. And so we just do what two numbers multiply to C that add up to B. And so I'll do that right now. Okay, so I worked out the first 3. I just did A, what two numbers multiply to C that add up to B. And that's how I factor all of these. But D actually has the A term is not 1. So there we're going to have to factor it differently. We have to do A times C, so 2 times -2 equals -4. And what two numbers multiply to -4 that add up to 3? And that's 4 and -1. That multiplies to -4, and that adds to +3. So then we have to use the Punnett square. So you put the first term in the top left, so 2x squared. It's going to be a little bit small. Probably should make that box bigger. Bottom right, put the last term, so -2. And in the other two boxes, put 4 and -1. Doesn't matter which one you put where. But they do have to add up to the middle term, so 4x and -1x adds up to 3x. And then you take out your greatest common factors. 2 negatives here. You bring a negative out with it, and it'll be -1. Top row, 2x. Greatest common factor of the first column is x. And the last column, greatest common factor is 2. So this will factor into 2x minus 1. And x, and that's a +2, so x plus 2. So I'll do the same thing in the denominator. I just want to show you. Alright, so we have, when you do the greatest, or you work out the Punnett square, when both of the numbers that you come up with are negative, you always take a negative out. And you can always multiply back in. So 2x times x is 2x squared, 2x times -4 is -8x, -1 times x is -1x, and -1 times 4 is +4. So that's how you can always tell that you get it right, the factors. So you have 2x minus 1 and x minus 4. Alright, let's look at what we got here. We have, let's see what we can cancel here. We have x minus 1, so those can cancel. And then we have x plus 2, x plus 4, so that's not an answer. We have nothing that can cancel here, so that's not an answer. B is not an answer. We have nothing that cancels here. That's not an answer. It's -1 here. -4, sorry, -4. Otherwise we wouldn't have an answer. So 2x minus 1, 2x minus 1, those cancel, and we have x plus 2, x minus 4. So D is the answer. Moving on, which is equivalent to the form of the expression here. So we look to factor the numerator. So first, if the first term is negative, always factor out a -1. It becomes, so then the squared term is positive. When you do that, it makes it a lot easier to factor. And b minus 7 over, and then we can factor, actually we won't factor the denominator. You could, but I actually see something. I see the factor up here, this trinomial b squared minus 11b plus 28 is the exact same thing as this trinomial down here. So when you have multiplication in the middle of two expressions, when you have one is in the numerator, one's in the denominator, they cancel, leaving you with a -1 times b minus 7 over b minus 4. If that didn't happen, where these trinomials would cancel, I would have factored them and then seen what I could cancel numerator and denominator. So this is the answer, but I don't see that over to the right here, so that must mean I have to distribute this -1, which leaves you with -b plus 7 over b minus 4, which is C. 10. Assuming the denominator is not 0, which expression is equivalent? So we have, so don't worry about the denominator is equal to 0, ever. Don't ever worry about that. That's just math notation. It's just not needed for solving a problem. What we have to do, we have denominators, we have fractions. So with fractions, when you're adding or subtracting fractions, we got to get like denominators. So to get like denominators, we need to multiply. Multiply by something is equivalent to 1. In this case, the easiest thing to do is take the second denominator, multiply first term by it, take the second term, and multiply by the first denominator. What this does is this gives us like denominators, and then once you get like denominators, your rules are to combine your numerators. So I'm going to factor here, or multiply it out, because this is a binomial. So 5x times x is 5x squared, plus 5x times x is 25x. And then so we have x plus 5 now and x minus 3, or x minus 1, plus, let's distribute this 5 to the binomial, 15x minus 5 over the exact same denominator. Once you get, we have like denominators here, and I don't multiply out the denominators. It's never going to help you to do that, so don't do it. But now we combine the numerators. So 5x squared plus, so 25x plus 15x is 40x, and then plus the -5, which is the same thing as subtract 5, over the denominator. You should look to factor the new numerator if you can. 5 times -5 is -25. What two numbers multiply to -25 that add up to 40? There's nothing, and then so we're good. That's going to be our final answer. Number 11, so we have n minus 15. So this is a fraction divided by another fraction. So the first thing you should do, keep a change to flip it. So keep that first fraction the way it is, change it to multiplication, and flip the second fraction so the denominator becomes a numerator becomes a denominator. I also see this 15 minus n is written backwards. I'd like to have the n first. So we have, it's a subtract n, so it's minus -n, and it's a positive 15, so plus 15. The reason why I'm going to do that is because this has n minus 15 up here, so n is first, so I want to be able to compare them. They're both binomials, and I want to see if they're the same, which now I can see they're not. But there is very similar, there's similarities here. And the similarity is, if I would factor out a -1, it actually switches the signs. So if I factor a -1 out of the denominator, it becomes n minus 15. So this is the equivalent to what I'm crossing out here. So that's the new denominator. By doing that, what it's going to end up doing is it's going to make, so we have a factor of n minus 15, and then the numerator is a factor of n minus 15. Those can cancel. And then we have a numerator here with 3/9 that can be reduced. 3/9 can reduce down to 1/3, and n to the 5th over n can reduce down, divide each one by n. So we have 3 times 1 now, In the numerator, we have 1 times n to the fourth is n to the fourth. And in the denominator, we have 3 times 1 times negative 1 is negative 3. Looking at the answers, none of the answers have negative denominators, so we just slide that negative up to the numerator, and we get none of the answers. Well, that's odd. So it should be, we'll just put a negative on one of them. So it'd be like B with a negative on it. All right, number 12. So I see fractions again. You can either do cross multiplying here, or you can multiply and get like denominators and then drop the denominators. So 3n is the common denominator. So multiply the first fraction by n over n, last fraction by 3 over 3. So we have n times 4n is 4n squared minus 37n equals 3 times 10 is 30. So once you get like denominators, you can multiply by the denominator then, and you drop the denominator. You have a quadratic, so let's move all the terms to one side, and we're going to look at either doing quadratic formula or factor. Actually, I'm just going to put this in the calculator. It should be easier. So I put it in the calculator. I saw I forgot the n here, so thank you for telling me. We have put it in the calculator, and what we're looking for a solution. It's the same thing as an x-intercept or a 0 or a root. So I can see over on the left side here, there's a solution, and there's another solution here. So to find the solution, second trace, 0, and left bound. So I'm looking at the tracer on the bottom, the numbers, and it's way down at the y value is negative 90. And what I'm doing is I'm going for the left solution. Now I can see the y value is coming up, and there I can see the tracer on the edge. And so now I'll put it on the left side of the x-intercept, hit enter, right side of the x-intercept, hit enter, and hit enter again. And there's one of my zeros at negative 10, so that's one of my solutions. And then I see that it crosses again over here on the right. So let's do it again. So we have negative 10, I'm going to do left bound, so I'm going to go all the way down, and the tracer is going to come back up around on this quadratic, because every quadratic is U-shaped, either U-shaped or upside down U-shaped. And you should be seeing it. There's the tracer on the left side. That's left. Enter. Asking for right. So we jump over to the right side of the x-intercept. Hit enter on guess, and we get 0.75. So we have x equals negative 10 and x equals 0.75. Oh, I guess we had it already at negative 10. But always try to find both solutions. Moving on. If no denominator equals 0, what is the solution set for the following equation? So here, easiest thing I believe to do is get like denominators. So you have x, 1, and x. Common denominator should be x. And all we have to do is multiply this first, or this middle term by x. And then I just drop denominators once they're all alike. So I have 1 minus x plus 2x equals 7. And gather like terms. So we subtract 1 to the right side. And negative x plus 2x is x. So x equals 6. There's our solution. That was easy. Looking at what part is only decreasing, so we're going to have to put this in the calculator, look at the graph. So put it in the calculator, the equation, look at the graph. We have to see what part is decreasing. So always start on the left side of the graph. This is increasing, and at this point here, it starts decreasing, and then it increases again. So we're looking at just the decreasing part. We go from the maximum, that's called a local maximum, to a local minimum. And how you actually find these is second trace, max and min. So we go left bound of the maximum, hit enter, right bound, says the question, right bound, enter, and we have negative 0.45. So what we're going to do, we're going to round these. So that's negative 0.45, and just for saving time, that's about 1.5. So negative 0.45 to 1.5, and here's your interval. So let's put in the next one. Graph it. So start on the left side of the graph, so it's decreasing, increasing, and we're looking for decreasing again, so that's from left side here all the way to this point here, which is about 2. So it's decreasing from negative infinity. Remember, I'm not talking about where it's coming from above. I'm coming from the left, because we're always talking about the x terms. So it's coming from negative infinity, and it stops decreasing. It's always the x terms at about 2. So negative infinity to 2. All right. Use the graph to determine the domain and range. Domain is the x terms. So if you take this whole graph and you squish it, just rewrite it, slide it all up and rewrite it on the x-axis, it'd be here. This graph would all go, so I'm squishing it on the x-axis, bringing that arrow down, it would go to the right, this arrow bringing it up, it would go to the left, and continuous from left to right, so this domain is negative infinity to infinity. And with the range, I'm going to squish it all to the y-axis, because that's what range is. So this arrow here would come over to the y-axis, and all this graph would squish over to the y-axis, all the way down, and this graph part down here would squish over, and it'd be a continuous graph from negative infinity to infinity. So domain and range are both negative infinity to infinity. Which arbitrary choice best represents the zeros and y-intercepts? Zeros are also x-intercepts. That's another name for 0. So we have, looks like it crosses the x-axis at -2, 0, and 1. So -2, 0, and 1. -2, nope, nothing in B. -2, 0, 1, I don't see. I see 0. I don't see 1 though. So already we are all the way down to A, and the y-intercept is also at 0, 0, so something wrong here. Shouldn't have 2 on there. Alright, domain range. So domain range, we've got to look at the graph. So graphing. So this graph is kind of weird, but we've looked at enough rationals that you should know that there's usually split into 2 different parts. So the bottom part here goes over to the left, top part goes over to the right. And so we look at domain. So the domain is all the real numbers, except there's a split here. So if you were to squish it all to the x-axis, there's a blank spot at, looks like 2. So domain is all real numbers except for 2. You could also look at the table. And you see at 2 there's an error. So that means all x values are good except for at 2. So that's C. It's the only answer that has that. Looking at the graph of the function here, what appears to be the domain. So domain, squish everything to the x-axis. So we have filled in circle here. This is already on the x-axis. Take that quadratic there, squish it all down to the x-axis. Filled in circle at 1. Squish this green part over to the x-axis. So there's an open circle at 2. Bring it all up to the x-axis. Bring this up to the x-axis, and there's a closed circle at 5. So we're looking at continuous from -5 to 1, and then it jumps again, and it's open, and it's not equal to at 2 all the way to 5. So there's 2 different parts to it. So we have -5 to 1, and then 2 to 5 with not equal to at the 2. Looking for the domain of the function of the next one. Again, put it in the calculator. So looking at the calculator, we're looking at the domain again. You can see that there's a break on the x here at 1, 2, 3, 4, 5, 6, -7. There's another break at 1, 2, 3, 4. Alright, just realized your test review is a little different. These answer choices are different here, and it probably was on the last, or a couple problems before that too. So you have, this is not 3, this should be a 4, and then a 4 here, and a -4, and a 4. So looking at the graph, you have an error at 4. Makes a lot more sense now. And no errors that way. I go down to 10 and then -10, there's another at -7, so we have -7 and 4 is where it's, except there's errors there, so -7 and 4. Number 21, end behavior, look at the graph. So graph this, it's a rational function, so we should see at least 2 different parts. And since we have 2 different parts here, so we have to look at as x approaches -infinity. So as x approaches -infinity, that's on the left side. So what's happening in the graph? It's getting closer and closer to 0. You can also look at the table and just go up to -infinity, just keep going bigger and bigger negatives. What's happening to these y values? They're getting smaller and smaller. It's a fraction, but if you put those into the calculator, those are all they get a lot smaller. So that's going to 0. They're getting smaller and smaller to 0, you could say. So it approaches, I guess in the last one is 0 here. So it approaches 0. Next one, number 22. When you're substituting these in, only look at the biggest exponent, the term with the biggest exponent. Everything else doesn't matter when you put it in the calculator. It's all about the biggest exponent. That gives you the shape of the graph. So let's look at that. So I'm just putting in -x to the 4th. If you chose not to cross out the rest of it, you can put any numbers in for B and C. Doesn't matter. Look at the graph, and so it's upside down U. So upside down U, which of the following describes end behavior? Well, as x approaches -infinity. So that's on the, as x approaches -infinity, that's left side of the graph. It looks like it's going down, so it's going to approach -infinity. The y value is approaching -infinity. So the following is the inverse. So we have g of x. That's going to become your inverse, means switch x and y. So I'm going to just physically switch x and y, and then you need to solve for y. Get y by itself. So add 5. Add 5. Divide by 3. Divide by 3. Get y squared equals x plus 5 divided by 3. And opposite of square is square root, so square root everything. And proper notation is this -1. That shows us math people that that's inverse of x plus 5 over 3. And if you look, you can also tell all the, so there's a multiplication in there, so you should see division. There's a subtraction, so you should see an addition. And there's a square, so you should see a square root. So that's D. Last one, you can read about it. Really all you're going to do is look at the equation, and we're going to do the inverse of it. So switch to x and y, and solve for y. So subtract 100, x minus 100 equals 5y, divide by 5, divide by 5, and inverse of f of x equals x minus 100 over 5. B. Moving on. Defined by the equation which represents the inverse, so it's the log function. Log functions always go through 1, 0. If you look at log, it looks like a 1 and a 0. So log function always goes through 1, 0. And if you found the inverse of that, it would be switch the x and y. Always just switch x and y. So that's inverse, so 0, 1. So inverse has to go through 0, 1. So A goes through 0, 1, B goes through 0, 1, C does not, so that's not right. And D gets close, but it doesn't actually go through, so that's not right. So it's either A or B. And the other thing, log function follows along the y-axis, and it curves over to the right pretty quickly. And with inverses, what it really does is it's this reflection across y equals x. So that line goes through here. So if you reflected this logarithmic function, log function, across that dashed line there, what would it look like? Would it look like B, or would it look like A? Hopefully you're saying A, because these points would all go up. So it's A. Which pair of functions are not inverses? So not a lot of times confuses people. So what I do is cross out not, and then let's do the problem. Which pair of inverses are functions, or are inverses? So again, it goes across y equals x, and that's, if I drew that straight, the blue line would be an inverse and reflect across to be the x. So that is an inverse, so that's not an answer. If you drew a line through here, g of x and h of x would be inverses, not an answer. Look at the signs. There's a plus here, there's a minus, there's a cube root, so those are inverses. Here we have a subtraction. Those are not inverses, so that's what we're looking for, D. And which of the following functions are inverses? So inverses, opposite signs. So we have, I see a plus 4 here. I don't see a minus 4 anymore. I see a divide by 2. I don't see a multiply by 2 anymore, so that's probably not going to be an inverse of anything. I see a subtract 2. I see a plus 2. I see a multiply by 4. And I see a divide by 4. So those are going to be your inverses. So g of x and h of x. Alright, on to compositions. So we have g of h of negative 2. Always with these, just start on the right side, farthest to the right, so that's negative 2, and that's going to get substituted in the h functions, h of negative 2. So start there. So we do negative 2, substitute in for x, minus 4. Negative 2 minus 4 is negative 6, so that's what h of negative 2 is, and then substitute that into the g function. So always start right to left, and just so you substitute, simplify, substitute the new simplified into the last problem. So g of negative 6, negative 2 times negative 6 squared minus 2. So negative 6 squared is 36 times negative 2 is negative 72 minus 1 equals negative 73. You have to substitute in the correct order, otherwise you're not going to get the right answer. So here's again compositions. We're looking at g of x. It's kind of confusing, but what you do is you start on the right, so x goes in the g. It's already there. It's already an x. And then you substitute g of x into the g of x again. So we're going to take g of x, what this is here, and we're going to substitute in for the x of each. So the first one is x squared, so it's substituting in x squared plus 2x for the x. That replaces this x here, squared, plus 2 times, and we replace this x with x squared plus 2x. Simplify this and we're done. So we have square, a binomial squared, so you have to do x squared plus 2x times x squared plus 2x, and then distribute in the 2x squared plus 4x. We still have to take care of this first part here, so it's FOIL it out, double distribution, x times x, or x squared times x squared is x to the 4th, plus x squared times 2x is 2x to the 3rd, 2x times x squared is 2x to the 3rd again, and 2x times 2x is 4x squared, and bring this second or last terms over. Let's clean this all up, get all of our like terms together. There's only one x to the 4th, 2x to the 3rd plus 2x to the 3rd is 4x to the 3rd. Just adding them together. 4x squared plus 2x squared is 6x squared, plus the 4x on the end. And so that will end up being B. Compositions again, which represents the composition, f of g of x, fog, sometimes as you hear it. So always start on the right, so g of x gets substituted in f. So we're going to substitute this g of x what it equals, and replace, substitute in for this t right here. So we have 2 times negative 4t minus 2. That's substituted in for t, plus 4. So distribute, so now we just simplify. So negative 8t minus 4 plus 4, and that cancels negative 4 and plus 4 to negative 8t. So that's D. Alright, number of possible permutations. Here we're just going to put it in the calculator. Permutations. So we're going to, first I guess you need to turn the calculator on. So with permutations, you hit the number first, go to the math key, go to the right to PRB, that's probability, and we do NPR. Permutations is NPR. If that has combinations, we do NCR. C for combination, P for permutation. Hit enter, and we're taking 3 at a time. Always big number first, then little number. so that's 120. Pretty, hopefully that one's a gimme on the test. Which situation involves a combination? Combinations are very general. They're not specific. So when we're looking at determining how many different ways 3 flavors of ice cream can be chosen, there's no specific way to choose those 3. The way the order, there's no order preference there. So A is a combination. How many different seating charts? Seating charts are very specific on where people sit. So that's a permutation. How many different ways 10 runners can we qualify top 3 advance? So the top 3 advance, there's no order to those top 3, so that is a combination. And the last one, how many different 5-letter passwords? Passwords are very specific on the order that you put the letters in, so that is a combination. So it's A and C. If we had this on a test, we would have select all that apply. Not here though. Normal distribution has a mean of 0. So what I do is I draw a number line, and on that number line, I'll put 0 and standard deviation of 2. That means so if I add 2 to 0, that's here. If I subtract 2 from 0, so distance, you're at -2. And that's 1 standard deviation away from the mean. And 1 standard deviation is 68%. Well, we need to do between -4 and 4. So if we do subtract 2 more and add 2 more, that's 2 standard deviations away from the mean. 1, 2, 1, 2. And that 2 standard deviations is always 95%. We have 68, 95, and 99. All right, next prop. So we're going to do, this is joint variation. Joint variation. So I always look for either joint, direct, or inverse. Circle it. What variable comes before that is always your y. So in this case, it's v equals, and it's always equals k no matter what. So it's always equal, that's my k. Make fun of it all you want. And then what the jointly is multiply. Direct is multiply, and inverse is divide. So after this, we're going to multiply by the height. So multiply by height, and multiply by the last one, the square of the radius. So we got to be careful there. Square of the radius. So we have to take the radius squared. And let's look. There's the equation. You just switched h and r squared. Use the commutative property of multiplication to switch those two. But that's the exact same equation. All right, looking at the next one, varies directly. So what comes before it is your y. In this case, it actually is y. It's always equals k. Direct variation is multiply, and multiply by the square root of x. So square root of x. And now inversely means divide. So we're going to divide everything by z. So always just go in the order it's talking about and know what you're talking. Direct is multiply, inverse is divide. What is the constant of proportionality? If y equals 16, so 16 equals k. K stands for constant. I know it doesn't, k is k, and you're thinking, well, constant's not spelled with k, but just think in this case it is. So I'm substituting all the numbers in for the variables. And so let's multiply by 2, multiply by 2. So 32 equals k times 2, divided by 2, you get k equals 16. All right, for this last problem, you go to stat button, enter, and enter in numbers. And we're going to go see what it says. It says exponential curve of best fit, so we're going to look at exponential. So you go back to stat, calc, go down to exp for exponential. Exponential reg, enter through, and let's write this down. So we have 12, 5, 8, so y equals sorry, I had a number wrong. So you should get 1,000 times 1.06 to the x. And now you're going to substitute 30 in for x. And because I'm short on time, that is c. So substitute 30 in for x, and that's your answer. Thank you.